All right. A large company has been hiring graduates from 2 secretarial schools. The company personnel manager gave a word processing and office skill test to all applicants for the secretarial positions. The test has a maximum score of 90 points. A random sample of 29 applicants from the first school. You see, we have first and second, 2 sets, 2 samples. So, question 11. Okay. The test has we have a sample of 29 applicants from the first school. So school 1, and then school 2. N1 is 29. He's gonna give you the mean and the standard deviation now. Had a sample mean of 68 points with the sample standard deviation of 16. So X1 bar is 68 and S1 is 16. Then an independent random sample of 25 applicants and 2. Once he says independent, guys, this is not section 8.3. You have to just run the 2 sample t-test here. Had a mean score of 71 points with a standard deviation of 12. At the 5% significance level, can we say that there is a statistically significant difference between the mean scores of all applicants from the 2 schools? Assume that population variances are not equal. I forgot to write this down. Assume that population variances are not equal. And once you see this statement, guys, that's a good hint to you. It's a 2 sample t-test. Okay, so he says check if there is a difference. So your HO and HA is going to be the following. Difference right here. That's the claim. And that's the null hypothesis. Any questions so far? All right, so let's proceed now. Okay, so 2 sample t-test. Let me bring the calculator up. Two sample t-test. Okay, it's stats. Okay, X1 bar is 68. Please do it with me as I do this one. 16, S1. N1 is 29. Now let's go to the other side. X2 bar is 71. S2 is 12. N2 is 25. And not equal. And you see where it says pooled? The 2 sample t-test has the pooled feature only. As I told you, if it says population variances are not equal, you select no. If it says equal, you select yes. So it's a no here. And if you want, we can do a draw to see the p-value in action. Oh, it's a big p-value. So you're gonna fail to reject HO for sure. So T is negative 0.7855, or to 3 decimal places, guys, it will be negative 0.786. And the p-value is 0.4358. So 2 sample t-test. T is negative 0.786. P-value is 0.4358. Okay. What did he say? Alpha here was 5%. So that's bigger than alpha, which is 0.05.
Mr. Bazzi?
Mm-hmm.
Wouldn't T be negative 0.785? Because after the 5 is a 4, so doesn't it just stay?
Oh, is it 4 or 5?
No,
No,
it's
it is 5 for me.
Oh, I might have put something in wrong. Okay.
Yeah, you would be right if that was the case. Definitely. So then you fail to reject HO. If I ask you justify your reason why you reject or fail to reject HO based on the p-value, guys. If the p-value is less than alpha, you reject HO. If the p-value is more than alpha, you fail to reject HO. So this implies that. And now, there is not enough. You can put sufficient if you want. Enough evidence at the 0.05 level of significance to support the claim. We are saying we cannot support the claim. To support the claim that there is a statistically significant difference between the mean scores of all applicants from the 2 schools. That there is statistically significant difference between the mean scores of all applicants from the 2 schools. We are saying that we don't think there is a difference. Okay, so that's the conclusion of this question, guys. Once we wrap up chapter 8 today, I can scan the handout for chapter 8 along with the worked out solution of all those problems we did in the second and this handout as well, and the additional handout. So that's 11, guys. We're gonna do now the next question, which is, I don't think we did 12, so let's do 12. There you go. A study was conducted to determine if the salaries of elementary school teachers from the 2 neighboring schools were equal. So would you guys agree right away with me for number 12? It's gonna be this. There you go. Now it hasn't happened for a while. Now the claim is in HO because he says equal. You know, a statement of equality is always in HO. So it did happen to be in HO this time. Let's continue reading. A sample of 15 teachers from each district was randomly selected The mean score from the first district was 28,900 with the standard deviation of 2,300. So let's write them down, guys. School District 1 and District 2. That should help you a lot when you label them like this, because when it comes to using the calculator, it will be very easy and smooth. So N1 is 15, and he says same number in from the other school. $28,900, and then standard deviation 2,300. Look, guys, if he doesn't say population standard deviation, then it's S, then it's a T test. If he says population standard deviation, then it's a Z test, which there is one question we're gonna do from section 8.1. But you notice most of the questions here in this handout are from 8.2. So that should give you a hint how important this section is, more important than 8.1. The mean from the second district was 30,300 with a standard deviation of 2,100. Well, teachers get paid more than that now, so that shouldn't discourage you from becoming teachers if you want to. Test the claim that the salaries from both districts are equal. Assume population standard deviations are equal. So here pooled is going to be yes, guys. So it's a 2-sample t-test. All right, let's do it. There you go. Two-sample t-test. Okay, X1 bar, 28,900. S1 is 2,300. N1 is 15. X2 bar is 30,300. S2 is 2,100. N2 is 15. And equal here, and not equal, the alternative hypothesis, and pooled is yes. There you go. So T is negative 1.741. And p-value, let me record the p-value, and I don't need the calculator anymore. 0.0927. Okay, let's see what he says here. What alpha? We forgot to write alpha down. Alpha is 0.05. Right here, guys. Fail to reject HO. Would please one student just give me the conclusion, please. So how do you word that? Remember, the claim is in HO this time, and we failed to reject HO. Okay. Who's gonna share the conclusion with me? Anyone would like to give a conclusion? What would it be, guys?
It would be there is not enough evidence at the 0.05 level of significance to support the claim that
No, there's not enough evidence
at the 0.05
to reject the claim. Because the claim is in, you see, look, the claim is in HO, and we say we don't reject HO. That means we don't reject the claim because the claim is HO. So we're just saying not enough evidence to reject the claim. Remember, guys, you use the word reject in the statement here when the claim is in HO. So there is not enough evidence at the 0.05 level of significance to reject the claim. So we're saying probably the claim is good. We're not rejecting it. To reject the claim that salaries from both districts are equal. So they probably are equal. And look, guys, look at the averages. They were very close. Standard deviation were very close. So that's why we couldn't reject the claim that they are the same. And here it is. Okay, I'm gonna pause for 1 sec. So next question is 16. 2 different methods for teaching French vocab were tried on 2 independent groups. Method 1 was used with a group of 40 students selected at random. Method 2 was used on another group of 42 students selected at random. Okay, so we have N1 and N2. Question 16. Method 1 and method 2. N1 is 40, and he says N2 is 42. After 1 month, the same vocab test was given to both groups. The average score out of 100 for the group using method 1 was 89. So X1 bar, guys, is 89. With a known population standard deviation of 4. You see the language here, known population standard deviation of 4. So you put sigma 1. The average score for the group using method 2 was 86. And again, with the known standard deviation of 5.5. So sigma 2 is 5.5. Test the claim that the students taught with method 1 performed better on the vocab test. All right, guys, perform better. Better means more than. So look, HO and HA. Mu1 is better than Mu2, bigger, that's the claim. And because, guys, he gives you sigma 1 and sigma 2, it is a 2-sample Z test. It's number 3 on the calculator. No pooled here. Don't care about pooled. We already know the population variances. So it's a 2-sample Z test. Okay, let's show you how to do this one. So that's a review of section 8.1. Stat tests. Number 3, as I told you. Okay, see, he wants sigma 1 and sigma 2, the first thing. Uh, 4, then 5.5. X1 bar is 89. N1 is 40. X2 bar is 86. N2 is 42. And we want greater than. Always, guys, before you hit calculate, you look for the sign in the alternative hypothesis and select it. And now it's not selected yet. I have to press enter. Now you see it's selected. And we can do a draw. The p-value will be on the right because that's a right tail test. Oh, it seems like we're gonna reject HO. So Z is 2.83, 2 decimal places. And look at the p-value, guys, 0.0023, which is very small. You didn't even see any shading. See, barely any shading right here. So Z is 2.83 and p-value is 0.0023, which is less than alpha. What alpha did he say here? 1%. Even alpha is 1%, still this is less. So reject HO. Would a student tell me the conclusion, guys? We rejected HO, and the claim is in HA. So what would that be? Yes. I'm sure some of you know how to state the conclusion.
Is it there enough evidence at the, I'm sorry, 1 second, I don't know what the
0.01.
the 0.01 level of significance to support?
Yeah,
the claim? Okay.
yeah, that's it. You need to practice it, guys, to get it. There is enough evidence at the 0.01 level of significance to support the claim. And if you don't remember what the claim was, guys, just look it up. It's already there. Test the claim. I'm not reinventing a wheel, guys. You just copy it. Students start with method 1, perform better than. Students start with that. Student start with method 1, perform better on the vocab test. All right. That is, this is another review of section 8.1, guys. So that's good that we managed to review this one today. Okay. Okay, this is still chapter 7. 17 is chapter 7. We're gonna go to 18. Okay, for 18, guys, I'm gonna pause for 1 second or a minute until you guys put the data here in L1 and L2. A university wants to see whether there was significant difference in age between its day staff and evening staff. A random sample of 35 staff members is selected from each group. The data are given below. Test the hypothesis that there is no difference in age group between the two groups. What does no difference mean, guys? What would that be? No difference. It means equal to. mu1 equals to mu2. And assume that population variances here are not equal. Let me just put this. Means pooled is no. Okay, so to do question 18, HO, HA, no difference means equal. So the claim right here, guys. Okay, and now let's run the test. To sample t test. Okay, it's data this time. I have I don't have summary. I have the actual data. See now how it changes lists now, L1, L2. You don't do anything. L1, L2, frequency, never change those, and not equal to. Sorry, go back. not equal to, and then pooled is a no. I'll make sure that this statement is given in the problem so you know whether it's yes or no. And here you go. No, it's a big p-value probably. So we're gonna fail to reject HO. So T is negative 1.680 if you round to 3 decimal places, and the p-value is 0.0976. Okay, at what level he says alpha is 5%. So it's very important to write down the value of alpha to sample t-test, guys. Okay, T is, again, let me show it to you, negative 1.68. P-value is 0.0976. I don't need calculator anymore. And now we can work this out, which is more than alpha. So you fail to reject HO. And here you say there is not enough evidence at the 0.05 level of significance to reject the claim. Why? Because the claim is in HO, guys. You say don't have enough evidence to reject the claim. You fail to reject HO, and the claim is HO. If you guys replace the word HO with the claim, so will be fail to reject the claim. So there is not enough evidence at the 0.05 level of significance to reject the claim. And you just see what the claim is and write it down.
Can you just one more time how you determine that HO is going to be the claim?
Oh, okay. Look right here. Test the hypothesis that there is, what does it say here? No difference. No difference means equal.
Okay, thank you.
Does that make sense?
Yeah.
Yeah. So to reject the claim that there is no difference in the age between the two groups. It's a very important question you ask. It's very important, guys, to know where the claim is, because everything will change at the very end. The last statement you make, it's all based on where the claim is. If you put it in the wrong spot, then you will be addressing a different claim. So you'll be answering a different question. Okay, so there is not enough evidence at the 0.05 level of significance to reject the claim that there is no difference in the age group. So probably there is no difference. Okay. Okay, let's see what the next question we're gonna do. Excuse me. So we're doing exercises from the second handout that has exercises from chapter 7 and 8. Number 9, 2 classes of pre-calculus students took an exam to place them into either advanced placement AP or regular calculus the following year. Given the following data, can you reject the null hypothesis that as groups, these classes are equally prepared for AP calculus? Equally prepared, guys, means equal. So if we do it right here, mu1 equals mu2. That's the claim. And how did I know that? From this word right here. Okay, guys, we're gonna put this in L1, L2, or you can put them in L3 and L4. If you don't want to delete, for example, the lists that you had, you don't have to put them in L1 and L2. I'm gonna put them in L3 and L4. Watch. So that's L3. See, you could see something like that on the test. There's not much data, so you should be able to deal with it. L4, 46, 53, 50, 52, 54, 51, 49. Okay, and stat, it's a 2-sample t-test, guys. Data. Now, my data is not in L1 and L3, it's in L2, it's L3, L4. So just go here and press the second key and then number 3. Then the second key and then number 4. And then not equal to right here. Pooled. Assume population variances are not equal, so it's a no. And hit calculate. Okay. So T 2-sample t-test. And pooled is no. T is 4.253, guys. P-value is 0.0028, very small, which is less than alpha, and that's all I need from the calculator. Reject HO. There is enough evidence at the 0.05 level of significance. What's the magic word, guys? There's enough evidence at the 0.05 level of significance to, the claim is in HO.
Reject.
Yeah, to reject the claim. That's it. That is number 9. And number 10 is the same thing, guys. You put the data in L1 and L2 and run 2-sample t-test. I'm just gonna write this. And this is 2-sample t-test for number 8 as well, if you wanna take notes. So, yeah. This is a 2-sample t-test for number 11. We did 12. Okay, we're gonna do number 13. This is section 8.4. All right. In 1975, a random sample of 1,484 adult USA citizens was surveyed, and 193 strongly agreed with the statement, people should take care of themselves. Then in 1991, a survey of 1,013 adult US citizens showed that only 61 strongly agreed with the statement. Does this indicate that the proportion of US adults who strongly agree with the given statement has dropped? How would you state the null and the alternative hypothesis here, guys? Dropped. It's a proportion. Now, students ask me, how do you know it's a proportion? It does say proportion here. So it is a proportion. So question 13. That's from the second handout. So P1. Okay, this is that you can do 1975, and then you can do 1991 first. And then N1, guys, is 1484. X1 is 193. And N2, 1013. And X2 is 61. And he wants alpha. He didn't say alpha. I'm going to use 0.05. I want the students to help us figure out. Okay, he wants to see if the proportion the proportion has dropped. The drop means become smaller. So which one is it gonna be? So he wants to see if, okay, when something drops, so it goes from big to small. That means in 1975, the proportion was higher than the proportion in 1991. So actually, it's the other way around. It's a P1 greater than P2 because yes, it dropped. That means P2 is smaller than P1. But because I put 1975, if I put 1991 first, then you would be right. There will be less than. But I put 1971. That means this one was bigger than that one. And it's the same thing, guys. If I say I'm older than you, then if you start with you first, you say you are younger than me. So it's the same statement. And that's the claim. This is a two proportion Z test, guys. Very easy test to perform if you know what you're doing. Let's get to it. I think it's number 6. Number 6, yeah. And look, guys, X1, 193. N1 is 1484. X2 is 61. N2 is 1013. And P1 is, we said, greater than P2. And then hit calculate if you like. So Z is 5.67. And look at the p-value, guys. It's very, very small. So Z. And let me write the p-value and show you how to interpret that. And again, guys, don't ignore the E minus 9. E minus 9 means you have to move the decimal point 9 digits to the left. So that is 0.00000007. You guys, you can make it almost 0. It's almost 0. So it's less than alpha, of course. You don't need even to know what alpha is. It's so small. So you reject HO. And you support the claim. There is enough evidence at the 0.05 level of significance to support the claim that the proportion of US adults who strongly agree with the given statement has dropped. Support the claim that the proportion of US adults who agree with the statement has dropped. All right. So that is question 13 from the second handout. I want to see if I can find one question from section 8.3. I think so. This one, that one we did. No, we did this one. Okay, I'm just gonna find one more exercise from section 8.3, and then we'll do something else. Okay, Captopril is a drug designed to lower systolic blood pressure. When subjects were treated with this drug, their systolic blood pressure readings were measured before and after the drug was taken. So this is dependent samples. And the subjects, guys, A, B, C, D, are patients before taking the drug and after taking the drug. Results are given in the accompanying table based on data from essential hypertension, effect of an oral inhibitor of angiotensin converting enzyme by McGregor et al. So that's real data, guys. British Medical Journal, volume number 2. See, this is real data. That's the beauty of statistics, guys. You get to work, just with real data and see and make some inference about the population based on that. Using a 0.01 significance level, is there sufficient evidence to support the claim that Captopril is effective in lowering systolic blood pressure? Okay. When you have something like that, a table with before and after data where the samples are dependent, guys, we don't work with before, we don't work with after, we do with the difference. And the claim is that drug does lower the systolic blood pressure. So here's how you work it out, guys. Let's do the difference first. For the first patient, his or her systolic blood pressure was 200. It went down to 191. What's the difference, guys, between the two? 200 minus 191 is what? 9. So do you think it worked for this patient? It lowered. So it did work, but did it lower it enough? That's the question. What's the difference for patient B? 174 to 170. That's a 4. That's good so far, but it's not much probably. 198 minus 177, guys. That's 21. That's good. 170 to 167. That's a 3. All right. 179 to 159. That's at 20 points. So guys, before even I continue, do you have a feel what your null and alternative hypothesis is going to be? Remember, when we met on Monday and talk about it, we want to test the mean of the difference against 0. And I told you, you're going to have either equal, less than or equal to, greater than or equal to 0 in here. And here you want to have not equal, greater than, and less than. Okay. Do you guys make an impression that it seems like the difference, we want the difference to be positive because we want the numbers after to be lower than the numbers before if the drug works? That means if you subtract a bigger number from a smaller number, it's going to be positive. And look, here's a hint. positive, 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 positive. So it should be easy for you to figure out that this is going to be, guys, your alternative hypothesis, the greater than zero. That will be your alternative hypothesis right here. So if I want to write HO, if I write HA, it's going to be mu of D greater than zero and mu of D less than or equal to zero. And that's the claim. And look, the hint was here again, guys. Plus, 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 positive. So at least that's a hint. I should choose this one, greater than zero. Okay, let's continue with the differences. 182 minus 151. So I kind of have a feeling that the drug works. We'll see. It looks like it's working. 193 minus 176, that's 17. 209, 183, guys, 26. 185 minus 159, that's 26. 155 minus 145, it's 10. You see, it's all positive. 169 minus 146 is 23. And finally, 210 to 27 is 33. All right. And he says use alpha equals 0.01. So when the samples are dependent, guys, you don't work with a two-sample t-test. Two-sample t-test is only for independent samples. You subtract before minus after, and you decide on which one you're going to use here to test it, and then you just run a t-test. And let's show you how to run the t-test here. All right, guys, so let's see. Turn the calculator on, stat, t-test. But before I run the t-test, I need to enter the data into a list. I'm gonna put my data in L5. Just show you I could use any list I want. So let's do that. 9, 4. So I think we're gonna reject HO. It seems like it's working here, but let's wait and see. The only question is the drop substantial enough to say that it's working? That's what we need to know. There you go. So I got the data. Now I'm gonna go to stat tests, t-test, and data, guys. U0, it's against 0. Section 8.3, guys, you don't change the 0 here. It's always against 0. L1 is 5, it's L5. And greater than. There you go. And let's draw. It's a right tail test. See, barely any p-value. That means that the drug is effective. So T is 6.37 and the p-value just use 0, almost 0. 371. If he asks you to round the p-value to 4 decimal places, just put this, which is, of course, less than alpha. Reject HO. And there is enough evidence at the 0.01 level of significance to support the claim that the drug is effective in lowering systolic blood pressure. And guys, this is what the FDA, the Food and Drug Administration, require before they approve a medication, but definitely not with only 10 patients. We're doing it just for the sake of simplicity here with 10 patients, but it will be thousands of patients. So that's, and different constraints, etc. But that should give you a very good idea of how statistics is used in real life, just to make decisions, make informed decisions. It's very, very important, especially this chapter here. All right, so